Not a, sorry. Good to record that, but too bad. I forgot. Okay, if there's no questions, I'm going to jump right back into where we left off. All right, you are going to work. Come hither. All right, there we go. Okay. So chapter 8 is basically the second real application of factoring that we see, right? You're just not gonna, it's still me. Hey, let me see. So, we've done stuff like this so far. Somebody help me out. Remind me what values can X not take on? Something like this, 4 over X plus 5. What values could X not be?
-5?
Yeah, why is that?
It would be 0.
What would be 0?
The bottom.
The bottom, I love it. So the thing is, you say it in English, bottom can't be 0, right? We know that you can't divide by 0. The bottom can't be 0. So the bottom is X plus 5. Can't be is not equal to. 0 is 0. So if you solve this, you get what X cannot be. Let me stop there for a minute. Oh my goodness. Where did you guys move over? My little tiny place. Okay, now, what if I have this problem? Same instructions, right? But it looks like this. I keep doing the same one, don't I? It's too bad. Too bad. All right. Let me see if I can do this. Is that better? Or is that from the, oh, that's from the laptop screen. There's nothing I could do about that. Oh, do it. Nobody? What do I do first? Why is it different from this one? Because this one, I can solve it. It's actually not, sorry?
It has an exponent?
Yeah, so it actually has the same first step. The bottom can't be 0. So then the bottom, here's the bottom, can't be 0. But to solve this, of course, what do I have to do? How do I solve this? Because of the fact, like Jamie said, there's an exponent, not 1. It's there, so I have to do what?
I don't know what it's called. Is it factoring, but the 2 X's in parentheses?
Yeah, factor. That's all I wanted was factor. So whatever method you have to use to factor, in this case, it's called trial and error. Right, 2 numbers that multiply to be 10, add to be -7. I'm just going to cut to the chase. So then X minus 5 is 0. Not 0. Or X minus 2 is not 0. So I get X can't be 5 and X can't be 2. I don't know if you guys can see all that. All right, let me stop for a minute. So this is combining 2 things we know. The bottom can't be 0 and factoring, right? So the bottom can't be 0. How do I solve this? I factor, and then I get the 2 values. X can't be. If I plug a 5 in, I get something over 0. That can't happen. I can't let that happen. All right. So not seeing any questions. I'm going to keep on going. Yeah. Here we go. Oh, let me erase. So what if instead of that I had this, it says simplify. The instructions are simplify. Let's see, what do I want? Oh yeah, let's do this. Well, I like it. Sure. It's nice and simple. How do I simplify this? What must I do? Can I just say 3 goes into 9? I can just reduce that, and then I can kill an x, and then these kind of cancel each other out. Yay! No, of course not, right? This is what I hate about this. I can't see everybody's faces to tell how totally like, what the shit's going on? So again, I know how to reduce fractions. We all know how to. We're just not used to seeing them like this. But we do the exact same thing. I just can't do it as easily in my head. I've got to show it to myself. So what do? We factor. How do I factor the bottom of this? How many terms are there?
2.
2. And it's a squares, right? It's a difference of squares. So what's 9x squared?
3x.
3x and 3x.
3x.
1 is 1 and 1. 1 is negative, 1's positive. Let me stop for a minute. So nobody had questions about anything, which means you all know factoring, because nobody asked any questions about factoring. And if you know factoring, the first part of chapter 8 is pretty simple, because it really is factoring. Now, what do I do now? What can I do now?
Reduce the same term.
Yeah, what's the same on the top as it is on the bottom?
3x.
Yeah, so what's the answer?
1 over 3x
Yes, good.
plus 1.
That divided by itself is 1, and the 3x plus 1 is on the bottom. Now, just to show you again, if you don't believe me that I just did the exact same thing you would if they were just numbers. I totally did. So if I had, for example, 45 over, what do you got, Jeff? It doesn't matter, dude. Just write it down. Sure, 55. What goes into both of those?
5.
5. So wouldn't you write this, isn't 45 5 times 9? And 55 is 5 times 11, right? And then what can cancel? The 5s can cancel. Same way that we killed those 2, because that number is the same as that number. They're the same number. They're the same number. You're dividing multiplications, so that's what makes those cancel. So then you get 9 over 11. So the exact same thing happens. It has to the exact same thing. It just doesn't look the same. That's all. All right, I have no idea how you guys are doing with that. Let's try another one. Let's see, what about this here? Sure. Yes. Okay, I think that should work. Yes, it will work. Yay. So again, I've got people out there right now that aren't listening to me. And when they see this problem, they will cancel the x squares. They will cancel the x's. They'll reduce the 24 and the 20, and they'll feel good about themselves. And that is not good. Division cannot cancel addition or subtraction. It cannot. It can't. So that's why we factor the top and bottom, because now I've got multiplications that division can kill. That's its job. That's what division, it's a single-minded thing, right? It wants to kill multiplications. So if you factor, so go ahead and finish this out. Don't say anything out loud. Try to do this. Factor the top like it's its own problem. Factor the bottom. And then just see what's common and kill it. Let out some aggression. Hey, this math, duh. Whatever you got to do. are you? Right. All right, let me catch up to you guys. So it looks like the top can be factored like this. And it looks like the bottom can be factored like so. You guys, is that all right? You never know. I could get something wrong, either on purpose or just because I'm human. Is that okay, everybody? That,
Yes.
thank you. That needs to be simple. That needs to be easy. This is a, why is this easy? That's a 1. That kicks so much ass. It's 3 terms, no GCF. Now it becomes a number game. Right? What numbers multiplied by negative 24 had to be 2. What numbers multiplied by negative 20 had to be 1. That's why it's relatively easy. Even if we don't like numbers, you got a little calculator, it can help you out. Right? You guys with me? I hope you, all right. And then of course, what can I do?
Cross out x minus 4.
Yeah, x minus
Top
4.
and bottom.
It's the same number on the top and bottom, so I can kill them. Die, die. So then the answer is that. And, you know I've done this before. I don't care. If x was, let's just say 1. I can pick any number I want to, right? Everything I'm writing in blue right now is nothing that you ever have to do. So as soon as I say that, I wonder if people are like, all right, I ain't gonna watch this shit. But if x is 1, isn't this 1 plus 2 minus 24? Right, if x is 1, this will be 1 plus 1 minus 20, which is 3 minus 24, negative 21. 2 minus 20, negative 18. And now watch, what would this be? If x is 1, this would be 7 over 6. If you reduce this, that's what I got from this, that's what I got from this, and I am saying that those are equal to each other. Sure enough, if you reduce this, divide by negative 3, divide by negative 3, it does become 7 over 6. And the reason this is not easy is because it works for every possible value of x. That is actually remarkably interesting. Because again, it's not just me being dramatic and trying to overblow things. We actually did just factor in, reduce. We just reduced an infinite number of fractions in that, bam. So in that regard, that's a lot easier than you would think it would be. Let's reduce an infinite number of fractions. No, but that's what we just did. It wasn't that hard. Okay, maybe. Maybe. Okay, so here's the next level. Somebody remind me, how would you do this here? Let's see, yeah, sure. Yeah, I like it. Yummy.
Reduce 40 and 25 by 5 and 18
Yes,
and
good.
27 by 9.
So look at up and down, right? Anything up top and anything down below if they have the same factor. So let me do one extra step that we normally would. 18 is 9 times 2. 25 is 5 times 5. 40 is 5 times 8. And 27 is 9 times 3. You probably wouldn't do this step. But now I can see, sure, right here I could tell a 9 would cancel, but I can see 9 cancels. Here I can see a 5 cancels. And then I get 16 over 15. So guess what we're going to do? If I have variable expressions in there, we're going to do the exact same damn thing. We have to, because variable expressions are numbers. So they have to act the same way. What is all this, Jeff? I don't know. I'm sorry. I don't know. So if I had this, what you got, Jeff? I don't know, man. Sure. Yummy. Look at that thing. That is just so yummy. Now, you know a math teacher would love this problem because it's actually 4 problems in one, right? You guys see that? That's supposed to help you, though. If you realize that's what this is, that's a problem, that's a problem. Well, that's probably going to be a bigger problem than it should be, and that's a problem. My suggestion to you is, if you ever see a cubes, do that first, because something else might be the big dude from the cubes, and it'll just die immediately. Don't waste your time. So do the cubes first, and then try to do the other stuff. I'll give you a few minutes. Don't say anything. Don't type any answers. I'm just going to stand here awkwardly. Or I tell you what, I know what I'm going to do. I'm going to blow my nose. Woo! So let me catch up to you. I'm actually going to put it up here, I think. Okay, so if I take this piece of it, that one should be really, really nice, right? How does that factor this piece of it?
X minus 3 and X plus 3.
Like it's just the difference of squares, right? It's 2 terms, no GCF, obviously squares. So one of each, bam, X, 3, 3, minus plus, bam.
Yes.
So the bottom,
X and X cubed
yeah, you got a little dude.
and minus 3 plus 9
Whoa, what's happening?
is an X and X squared.
No. What's
No?
that? Oh, I see. An X and an X
X
squared,
squared.
sure.
Yes.
What goes here?
Minus 3.
Good, because this is X, 3, 3,
Yeah.
3.
It's
1X and 1, 3, I got you.
positive 3.
No, minus 3.
Yes. And here is gonna be positive 9, but we have to put positive 3 before positive 9 to cancel the
Not just 3,
X. Sorry.
3X, I like it. So 1X, 2 X's, 1, 3,
Yes.
2 3s, and then
Yes.
3X, bam.
Yes.
Opposite
same.
sign. I like it, thank you. That's how you do cubes.
I forgot the X.
And then look at this. Why I'm not even going to try to factor this thing because it's going to die. It's just going to die. It's dead, right? It's dead. You can't factor it. That's why I say do the cubes first. Otherwise, you're going to stare at this thing for 5 minutes and you're going to run out of time for whatever it is, right? But here I can see I don't even have to waste any time. It's just going to die. Now, how do I factor the bottom here?
Why is gonna die? Can you show me why?
Because they're the same.
Okay,
Right?
the same.
What is something divided by itself?
Yes, yes, yes. Because you go this with another. Okay, I got it. I got
Okay.
it.
So if it's the same on the top and the bottom, they don't like disappear. They just become one. And of course, one doesn't show up, right?
Okay.
All right. Now, how do I factor the bottom here?
X plus 3 and X plus 6.
All right. So let's see what else cancels.
X plus 3.
Yeah, the X plus 3's cancel. The X minus 3's cancel. So what's the answer? What would
1
you tell
over
somebody?
X plus 6.
Yes, good. If they put this and they're like, well, that's because that's the only thing left, you would just say, well, it is on the bottom. That's where X plus 6 is, right? And what's on the top? Well, everything canceled, so 1 is on the top. So again, if you are pretty good, if you're okay, decent with factoring, this should be relatively simple because it really is just factor, 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 and then cancel, 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 right? The only new step is canceling, and that's not a huge step. You get to kill stuff, which should feel kind of good. Die, algebraic expression, die, right? All right, maybe. So, oh, who's got something? Everybody all right? What's up? Somebody's heavy breathing at me. I'm going to mute everybody because you're freaking me out. Okay. So somebody help me out. How would you do this problem here? You can do it, Jeff. Well, I like that problem. It's gross.
Flip
Remember-
28 and 35.
Yes. So when you divide fractions, you multiply by the reciprocal. And then you do all the same shit. You do all the same shit. Right? 14 goes into 28. 5 goes into both of those. Right? So then you end up with 7 over 6. So if I have a division symbol in between expressions, I first flip the second dude and then do all the same stuff we just did, right? So division is not any different than multiplication because the first step of division is make it become multiplication. Okay, maybe? Okay, so let's try a little quick, let's see what we can do with this. Let me do something nifty here. Sure. Well, weird, Jeff. Oh, well, we'll deal with it. We'll see what happens.
So you flip m squared minus 4
So
and
first
m.
thing you do, m squared minus m over m plus 2 times m cubed plus 2m squared over m squared minus 4. And, you know, as you do that, you can factor things, so you're not writing as much, but still, then you factor this. How do you factor this?
Take m out.
Yes, GCF saves your ass, right? Take an m out. The bottom I can't do anything with. This one I can take
M squared.
m squared out. And over here I've got,
Differences of
Yeah.
square.
so I was kind of, oh, I like this problem. I like this problem.
So
This
when
is such
something
a
is
beautiful
prime, you always just write it as is and keep moving.
Like, are you talking about like this bottom piece?
Yeah,
For
and one in the previous one that was prime that you couldn't
Yes.
use anymore.
Exactly. You just leave it as is, and maybe it's going to die, and maybe it won't. So if you notice, what cancels here?
M plus 2 is a common factor.
Good. The mistake people make sometimes is they'll somehow kill that and this. These are dead. Nobody's left to kill him.
Mhm.
What about the M's? Can I cancel one of the M's?
No.
That might seem silly to some of you guys, but you know, it's because they're not on the top and the bottom. That's the only way they can be opposite operations. So then what would the answer be? It would be M cubed, M minus 1. You're going to collect all the survivors now over M plus 2 times M minus 2. And please, there's no reason to multiply stuff out in your answer. You could just leave it factored so you can really see that nothing is left to die. Nothing else wants to die. Die. All right. I'm in a weird mood today. When am I not in a weird mood? All right. So let's see. One last idea, and then I want to take a look at that handout. So it really is, so division becomes multiplication. We know that about fractions. And then it is all about being able to factor. Because then the next step is relatively simple. Just kill anything that's the same on the top and the bottom. Because now division can do its job. So it is very much dependent on your ability to factor. Okay. So, help me out here. What can I do here? Yeah. Anybody?
5
No
over 9.
trick.
Add 2 plus
Yeah,
3.
yeah. Why am I allowed to add these? Because 2 ninths plus 3 ninths is 5 ninths. It's just like terms. But I need like denominators so that they are like terms, correct? So, what's this? Got it. You can do it, Jeff.
Six M plus 1. 6 over M plus 1.
Yeah. So it's 4 of these plus 2 of these is 6 of these. Why was I allowed to do that so easily? Because they had the same denominator. So now what about this here? Don't say anything out loud. Try to do this yourself. Do what, Jeff? I don't know. Okay. Well, that would be a little evil, wouldn't it, Jeff? It doesn't matter, dude. Keep going. That'll work. Sure. I like it. I like it. So let me check in with everybody. Am I allowed to add the tops together?
Yes.
Yes, because the bottoms are the same. They have like denominators. So what is 4x plus 5 minus 3x?
X.
6x. No?
You only put your like
2x
terms
plus
in, so
4x.
let me write it all down. The only like terms up here are 4x and 3x.
Minus x squared.
4x minus 3x is?
4 and 5 is
No, stop. You can only put together like terms. I can't put together 4x and 5. They're not like terms.
okay.
I can put my x's together. What's 4x minus 3x?
1x.
1x plus 5.
That's it.
No.
Oh.
One more step. What do I always do at the end of a fraction problem? I check to see if the fraction can be reduced.
Oh.
X plus 5 divided by x plus 5 is?
1.
What? Right, because they both cancel. So as long as the bottoms are the same, I can combine the tops over that bottom. That's how we've done fractions forever. Just because these have variable parts doesn't mean they act differently. They're not allowed to do that. Little dorks. You got to do the same thing. So what about this here? Let me make something up. I know you can't really see this. I don't care. Hold on. I'm going to try to create it while I'm doing this. Ooh, do I want it to be so funky? Yeah, sure. Okay, Jeff. Why are you being so mean to yourself? I wish I knew. Let's see. Okay. Oh, that's right. There we go, Jeff.
Professor, I have a question.
Yes.
Okay, I'm confused with the x plus 5 in the bottom. The answer. Why you cancel? Why you got equal 1?
What is 7 divided by 7?
Okay, I got it.
So something divided by itself is 1.
Oh
Yeah.
my God, I got
That's
it.
okay. And again, don't feel bad. Your brain says to itself, hey, brain, what's up, brain? It says, all this shit's different because it's got X.
Confused.
It's all different shit. No, it's the same. It cannot be different. At the same time, it feels different because we're not used to seeing things like, we're not used to working with unknown numbers. But everything we do is the same thing we do as if we
Yeah.
knew the number.
Yeah, you're right.
Let me see. Look at this beautiful beast. This is such a yummy thing. Do they all have the same denominator?
Yes.
So I can just combine the tops. So let me start to put them in order. X squared plus 2x plus 8 minus 8x. So I combine all the tops over the bottom. Oh, I did the same thing. I didn't want to do this. I forgot what I was trying to do, but oh well. I made the same damn problem. So of course, what's this? Is everybody cool with that? What's happening up there?
Yeah, 1.
Yeah. All right. I meant to make a more interesting problem, but I just didn't. Okay, so let's take a look at this worksheet thing. So I can sit my ass down. You guys can see that still? Let me get out of there. All right. Here. So let's take a look here. Let me see. I want to look at this sheet I put up here. Holy sheet. All right, let's see. It's going to make me download it, isn't it? Just open. Open. Okay. So, why don't I have all my normal things? Weird. Oh well. So guys, right here, these two are just like the ones we just did. Everybody sees these, the number 3?
Yes.
Okay. Go ahead and try to do those. There we go. I'll sit here and stare at you. Maybe I won't. I'll do this instead. Ooh. Uh-oh. Is my internet all right? Ruh-roh. I wonder which one you can see now. Oh, I guess this one. Now, all right. Let me take a look at part A, because part B has something you got to really be careful about. Sorry, I got to open up this other version of it. Is this? Yeah, this is the one. So that I actually am able to type on it. So this one here, they do have like denominators. So what's going to really suck for us is when the denominators are not the same. That's the next thing we got to talk about, is what do we do when the denominator is not the same? We do the exact same thing, is it as if they were numbers. So, let me see, come on, let me do this. I can combine these. Get out of there. Because they are the same denominator, right? Is that cool? Everybody see that? 12x plus 6 over 2. And then that's the first thing you worry about. It's just getting things all together. Do they have the same denominator? If so, put them all together. Once you get them all together, then you think, can I reduce this? What can you do with the top? Can you do something with the top?
GCF.
Yeah, you can take a GCF. Take a GCF. What comes out of the top?
6.
A 6 comes out. And then what's left inside? Whoa, shit.
And same with the denominator.
That's right. If you take a 6 out of 12, that's 2. If you take a 6 out of 6, that's 1. So you end up, holy macaroni, you end up with that. So do you guys see that? Everybody good? Oh, man, I can't wait till we're back on campus. And then, of course, I can cancel the 2x plus 1s because they're the same. Let me see if I can do this. Can you do it, Jeff? Let me do it. Let me see. That's just taking too long, Jeff. Just let it go. Let it go. Let it go, buddy. It's all right.
It matters what order we put it in.
How do you mean what order?
So it can't be 6 plus 12x. It has
Oh,
to be 12x.
it totally could be.
Okay.
In fact, let's do that. So if you put it as 6 plus 12x, then it would have looked like this, right? Let me see. Let me get it all down there. It would have looked like that. Is that cool?
Yes.
And then, of course, even though it says 1 plus 2x, it's the same thing as 2x plus 1. So they still kill each other. So you still end up with, eventually, 6. Pow! Because those two things cancel. Just like anything would cancel that's the same on the top and bottom. Okay, maybe. What's the one thing you got to be careful about part B? The mistake that people make is they'll, oops, shit. Not that they'll shit, but hold on.
It's a minus.
Yeah, you got to be really careful about the minus. What are you subtracting here? You're subtracting. So if you write this, you are going to be wrong. Let me get it down here. This, my friends, is wrong. That is incorrect. Thanks for playing. Because the thing you got to notice, and the best way to write this, to be honest, is like this. Let me see. That minus sign has got to distribute. And the best way to kind of show yourself that is what, Jeff? Give me a minute. I can't get this written down fast enough. Oh, someday, someday. All right. Bip, bop, bip, bop. Man, that's really funky looking. Oh well. All right, you ready for this weirdness? That's the same thing, isn't it? Minus is plus a negative. You don't have to write it like this. You don't. You don't have to. You just have to remember that the minus sign in the middle needs to distribute. So then you eventually get to here. You can do it, Jeff. Can you? Can you do it? Be quiet. There it is. All right, let me stop for a minute. That would be, I didn't mean to overwrite. Darn it, Jeff. I just overwrote what was there. Good job, buddy. There we go. Why? Bam. Too far. So you could skip this step right here. You could skip it. If you're just careful, the minus x squared and the minus 4, you've got to change both signs because what's being subtracted, this whole thing, not just the x squared piece. Both of them are being subtracted. Now finish that up. Now that I did that hard step for you, do the rest. Oh, you boy. Sorry.
When you rewrote the problem, the middle one, why did the sign change to positive? Like I know x squared times -1 would be, so the one up from that. Why did the sign in the middle go from negative to positive when you rewrote it?
It really didn't. So I don't know if you guys remember, but something like, I'm getting tired of trying to write it, that stupid thing. So if I had like -7 minus 2, you can rewrite that as -7 plus -2. Do you guys remember that? Those are the same, those both mean the same thing.
I understand.
Okay. And in mathematics, we normally don't like to have multiple operations in a row, but sometimes it's very helpful. And like I said, you don't have to do that. It's actually better to not do that, but just in case you need to, you can. But you just got to remember that negative has got to distribute to both. If you write it like this, then it's just in your face that it's got to distribute. You're not going to forget it. So let me see. Let me catch up to you guys. So if you do this, on the top you get, dadgummit. Oh, it takes me forever to do a simple thing. Do. There, okay. You get there. Does that look right? Right, just combining all your like terms. And then of course, what can you do at the top there? What can you do with the x squared minus 9?
Differences of squares.
Yansha's over it. He says, the difference of squares, Jeff. Just do it. Just make it in. I understand. So then, yeah. So the top is a difference of squares. Because effectively, we're done with the problem to one extent. We have simplified it into a single fraction. The last step is just, can you reduce what you got? Which is what the last step is always when you have a fraction problem. You know this. You know that's the last step in a fraction problem. Can you reduce it? So why would that change now? It can't. Woohoo! Let me get over there. Bam! And then I can kill the x minus 3s. Why did it do all that? I don't know. Just let me write this, please. Okay. I sound like a Skeksis. Gelfling, please. Oh, scheisse. All right, just write it, Jeff. There you go, buddy. Why does the X look like that? I don't know. I don't know. What are they thinking? I don't know. They just realize you talk to yourself all the damn time. There it is. Look at the answer showing up like a champ. All right. So that's what we just did, right? Is this idea, and nothing's new. Nothing is new. You need like denominators before you can combine fractions. So this section, I think it's section 8, 3, maybe? I don't know. I don't remember. This whole thing about like denominators. And then the next chapter is all about unlike denominators, right? So right now we got like denominators. So what do? You combine them, and then you see if you can reduce. Combine them, and then you see if you can reduce. That can't change. That's the fundamental thing about that doing fractions. Yeah, and then these are going to be like the ones we were doing earlier, right? Where it's not adding or subtracting stuff. It is reducing fractions and dividing fractions, right? So I don't need an LCD. That's another, I'm glad I'm saying this. When I multiply two fractions, I do not need an LCD. That makes no sense. Because the whole idea with multiplying fractions is to try to reduce everything. And what's finding an LCD? Building things up. They're opposites of each other. You only need LCD when you need like terms. And when you need like terms, addition, subtraction. I don't know why I said it like that. Addition. In the industry of China. It's huge. All right. Yes. I think it's okay. You guys can finish it up, right? You want to do that? What time is it? No, I'll let you guys out. Is that all right? We could do those next time for a review if you want to. Tomorrow. Tomorrow is when we have the quiz on the rest of chapter 7. 7, 4, 7, 5, 7, 6. And then, of course, Thursday we have a quiz on 8, 1, 8, 2. 8, 1, 8, 2. There it is. All right, I think I need some lunch. That's what I need. Anybody have questions on, there's just too much there, is there? Well, I'm like really on there. Okay.
Thank you.
Anytime. So let me know if you need to hang out for a bit. Anybody have questions, need to hang out? If not, just go on and head out. All right, I'll see you guys.